Good morning, dear friends. During the last two sessions, we came to know what is the construction and working principle of bipolar junction transistor and the types of bipolar junction transistor, especially NPN and PNP transistor. Then we concluded with the activities in the interactive book. If you have any doubts, kindly go through the previous lectures which is available in the playlist of Power Electronics. Those who have not subscribed this channel, kindly subscribe as well. Today's session we are going to learn how to differentiate the region of operation in the BJT, especially understand the different regions in the working of the bipolar junction transistor. Normally, bipolar junction transistor has three working regions. First one is cutoff region, saturation region and active region. Let us go one by one. First of all, this is the circuit diagram which will give you the idea about the cutoff region. See, this is the NPN transistor. In the last lecture I told you the arrow mark is towards the emitter, so it is called as NPN transistor. So collector and emitter is nearby the N layer, base is in the P layer. Already you know, we are very familiar with that. Then the collector is connected to the positive supply through the collector resistance RC. Then base is a open circuit. We are giving base current as 0. Then emitter, the emitter is directly connected to the ground. If you see this structure of the circuit, you come to know this collector is connected to the N terminal, positive terminal is connected to the N layer and P is connected to the negative terminal. So both this junction between collector to base will be the reverse bias. Similarly, base is connected to the P layer and emitter terminal is connected to the N layer. So with respect to this, here it is negative, the P layer, the junction J2 will be also reverse bias. In this condition, whenever the base current is 0, there is a possibility of going minimum amount of current from collector to emitter, that is called as leakage current. So in this stage, BJT will be in off state and there is no current flow ideally from emitter to collector or collector to emitter. But this is in the NPN transistor. Normally current will flows from collector to emitter. Already you have already studied well. So now let us go and draw the waveforms, the collector current with respect to voltage across collector to emitter. If you see this, you can see there is, due to the minimum value of current, base current is 0, there is small leakage current will flow. Ideally we can see this will be 0, IB this will be 0, but small amount of leakage current only flows from collector to emitter. So this region we will call it as cutoff region. Then if we go to the saturation region, it occurs when the collector current is not depends upon the base current and has reached all the time the maximum value. For example, if you see this connection here in this saturation region, junction J1 and J2 will be forward bias. That means base will be connected to the positive terminal and collector will also connected to the positive terminal. Therefore, this junction J1 and J2, both the junctions will be forward bias. So in this stage, BJT will be the on state and maximum current will flows between emitter to collector. So this is the maximum current. So as we are making this arrangement like that, two junctions are forward bias. So this voltage will reaches one particular value. Then after that it will keep on increase here, right? So now this point, at the point at which the voltage between collector to emitter at the point at which the collector current will try to get maximum value. For example, here the base current is gradually increasing. So the collector current, based on the base current, it is keep on increasing. So this limit is called as saturation limit of voltage between collector and emitter. So this region is called it as saturation region. So in this saturation region, BJT will be on state, maximum current will flows between collector to emitter, while this junction J1 and J2 will be the forward bias. Then let us move to the third region, active region. In this active region, if you see this, we can have the base emitter junction will be forward bias and base collector junction will be the reverse bias. So what will happen in this active region, the base current, as the base collector junction, base emitter junction is forward bias, base current will flows through that. With respect to base current, we can see as long as base current is increasing, we have maximum saturated current of collector current. So this current is called as active region. This graph which will show you which region will be saturation region, which one will be the active region and which one will be the cutoff region. So from this we conclude that collector, this is the ideal characteristics of bipolar junction transistor. Bipolar junction transistor block the forward voltage. Here it can block the forward voltage, due to that this is extended to collector to emitter. Similarly, it will block reverse voltage as well, so that it is extended to that towards left side. Then it will conduct forward current, unidirectional current. It will not, current direction will not reverse. Already we have studied NPN transistor, current will flows from collector to emitter. PNP transistor, current will flows from emitter to collector. So in this case, only this is a unidirectional device, so therefore current will flows only one direction only. So IC is positive. So this is the ideal characteristics of the bipolar junction transistor. Collector and voltage across it will block the forward voltage as well as reverse voltage, and it will conduct the forward current. Then at the nutshell, we can see that cutoff and saturation region will be normally used for BJT as a switch. In our power electronics, we will use this BJT as a switch. So the cutoff region means what? Cutoff region is the off state of the BJT. That means there is no current flow in this in this base. Therefore this BJT will be in the off state. Then in the saturation region, in this sense, there is having a current flow in the base. Therefore, that IGBT will be the on state. Sorry, BJT will be the on state. So this is called as cutoff and cutoff state saturation. So switch will, BJT is act as a switch. It will be on during saturation region. It will be off during cutoff region. So that's what it is mentioned. When BJT is cut off region, act as a open switch. Therefore, open switch means it will block forward voltage as well as reverse voltage as well. Then when this BJT is in saturation region, it is act as a closed switch. That means current will flow. Therefore, collector current will increase to the maximum value. I hope now you understood from this what are the different region of bipolar junction transistor. So we will see in the next session. Those who have not subscribed this channel, kindly subscribe. Wish you all the best. Thank you.